1.
Welcome to the Laura and Melissa Show.
Hello, Honors Physics World. I am Melissa.
And I'm Laura.
And we are going to do our conclusions today. So, Laura, this is how the interview is going to go.
Okay.
I'm just going to ask you some questions. We're going to go section by section about your lab. Just answer the questions however you feel is necessary.
Sure.
Let's get started. Okay. So, for the build of your lab, please tell us, what did you learn? Can you prove it with some examples?
Well, to start off, the build of the rocket is obviously a very important part of the entire lab. The purpose of the build is to produce 4 identical rockets to be shot in later parts of the lab. While building the rockets, we learned things that are important to us now and will be in the future. We learned how to be extremely precise with measurements. For example, we had to cut every piece of tape exactly the same size so every rocket would have the same mass when we were finished. We also learned general safety rules for when we must build things. Most importantly, we learned how to transfer a design idea on a piece of paper into an actual 3D rocket.
That's great. It seems that you learned a lot inside the class and for future life. Now, Laura, tell us, what formulas did you use for the build? I can't expect that there are many, but I'm sure that there were some really important ones.
Well, one formula that we used in this lab included the circumference formula, C equals 2 pi r, or C equals pi d, the diameter. We used this formula to calculate the diameter of the bottle by
restructuring the formula, I assume.
Yes.
How would you restructure that formula, Laura?
It would be d equals c over pi.
Wonderful.
When we used the diameter, we found to locate the theoretical center of gravity, which is located 1 diameter up from the 80% line. We also used the circumference and divided by 4 to find the distance between each of our fins. While our results were pretty good, our masses were equal. In order to improve, we could have just...
Now that's how could you perfect it for next time? Laura, could you happen to tell us how you could perfect this part of the lab next time?
Sure. Well, we also used the circumference and divided by 4 to find the distance between each of our fins.
It seems like you did really good with the build, but Laura, could you tell us, how could you perfect the lab for next time?
Well, our results were pretty good this time. All masses were equal. But in order to improve, we could have just been more precise with our measurements and with the construction of the rockets, such as fixing the fins and making sure they were straight and making sure they were even and the same width between them on each and every rocket. Just little things that would have helped to perfect the lab.
Because we all know that one little thing in the beginning of the lab can really mess things up later.
Absolutely.
What were some of the group dynamics for this part of the lab?
Well, our lab groups worked very well together while building the rockets, and each did an equal amount of work. We met several times out of school to work on the rockets and tried to make sure we all spent the same amount of time on the build. Overall, this lab was very enjoyable, and it was a great opportunity to gain experience in actually building things that will be used.
The build seemed pretty fun, but were there any likes or dislikes that you can be specific with?
Well, overall this lab was enjoyable, and it was a great opportunity to gain experience in actually building things that will be used. I liked that we were able to have creative control over our rockets.
What other labs have you done that were maybe similar to this or completely unsimilar?
Well, this lab was kind of similar to other labs, such as chemistry labs, in the sense that measurements needed to be accurate and precise. However, it was different in the sense that the build of these rockets affected the outcome of 2 subsequent parts of this lab, making this extremely important.
So would you keep it for next year?
Well, this lab should definitely be kept for next year because it gives students experience in building things to be used for experiments and teaches them how to go from a design idea to an actual rocket.
Sounds great, Laura. We're going to take a break, but we'll be right back. Thanks for watching.